Hey Adam,
Hello Andy.
what are you up to?
Just trying to explain to these guys what IPv4 addressing is, but I don't know where to start.
Oh, I know about IPv4 addressing. Want some help?
Oh yes, please.
So what is IP addressing?
Well, let's explain it to them. IPv4 stands for the Internet Protocol version 4.
Wasn't that the first Internet Protocol version used worldwide?
Yeah, that's right. Did you know it's also the core standard for internet connections?
That's cool. It's also used within packet switch networks, known as the Ethernet. Let's explain what an IPv4 address looks like.
Yeah, okay then.
An address is made up of 32 bits. IPv4 uses an 824-bit system.
They use the first 8 bits for network identification.
The remaining 24 bits are used to find the end host.
Let's talk more about its structure.
Why don't we tell them about the binary involved as well?
Yeah, that sounds like a good idea. As we have mentioned, an IPv4 address is made up of 32 bits, which equates to 4 bytes.
These bytes are known as octets.
The computer recognises the address as a binary number. Yep.
Oh, I see. What do you mean by a binary number?
Well, we know that it's a 32-digit number, but it's also made up of a combination of ones and zeros only.
Let's see what it looks like then.
This is what it looks like.
To get an octet, you need to split these 32 digits into 4 groups of 8.
Right, we know what an IPv4 address is, what it looks like, and how a computer converts it.
Let's talk about how packets are sent from its source to its destination using IPv4 addressing.
Let's think of it as a delivery company when you're sending a package.
Each house has its own unique address, just like a computer has its own IP address.
The package is sent from your house, which is the source, with its destination and return address.
And then it's starting its route. The packet arrives at the sorting warehouse.
In computing terms, this is known as a global unicast.
Within the global unicast, the packet's details are examined.
Using a set of predefined rules, the packets are then organised by the details examined to find its remaining route.
The packet is then shipped out of the global unicast and sent on its way.
The packet arrives at the street of its destination, and then using that given address it locates the end host.
Let's explain a bit more about the global unicast.
That's a good idea. There are 2 governing bodies that act within it.
Firstly, IANA act as a government to manage the unallocated IPv4 address pool. They also oversee the allocation of address blocks to the RIR.
The IANA stands for Internet Assigned Numbers Authority. As we have already talked about the points shown, let's move on to the RIR.
The RIR is the distribution phase, who are self-regulated bodies that control the blocks given by the IANA and distribute addresses to ISPs.
They use set allocation policies to help them with their assigning process. RIR stands for Regional Internet Registries. Let's move on.
Let's conclude how data is sent.
The data is sent out in packets which are then sent to the global unicast.
The unicast is governed by the IANA and the RIR distributes the packets to their destination.
Let's check out the current status of IPv4.
IPv4 addresses are no longer unique identifiers, as the internet can now reuse them.
The amount of available addresses is rapidly decreasing, as shown in the following graph.
Since the early 80s, there was a steady rate of address allocations.
However, in the late 80s, early 90s, there was a sudden boom of allocations that has been rapidly increasing until today.
Due to this increase, there are roughly 4.3 billion addresses available for worldwide use.
A newer version of IPv4 needs to be implemented before we run out.
That ends our presentation.
Thank you for watching.